So this is our third part of the C++ basics, and today we're going to talk about preprocessor directives, debugging, and style a little bit. And again, these things will become clearer as you get more experience with programming. The best way to learn this is to get experience, and we'll have a lot of chances to write some code in this class. But let's go over some of the theory here. And the first thing to consider is preprocessor directives. And C++ has kind of a small number of operations, a relatively small number. And a lot of the things that you need are provided in collections known as libraries. So each library, the first one that you'll get introduced to is IOStream, has a name, and it's referred to by a header file. There are other preprocessor directives that you can include, but the ones we'll be focusing on are the libraries. They all begin with pound, and you don't need a semicolon at the end of these commands because they're telling the environment to do something before you begin compiling. So, for example, pound include IOStream means, hey, include that IOStream library. Pound include string means, hey, I'd like to use strings in my program. Please include that library as well. You can also put code in different namespaces, but for right now, it's enough for us to use the standard namespace. Since at the beginning of our program, we're almost always going to start things with pound include IOStream using namespace standard. And, that'll be it for the, beginning couple programs. But later on, we'll include things like C string, string, C math, etc., different libraries that we may be interested in using as we progress in our study of C++. And the main program is basically a collection of functions, or C++ programs are a collection of functions. Main is the function where the program begins, and it's one of the most important ones. So in general, it'll look something like this. It starts with int, which is the return type, and it's convention that it's int as a return type for main, so that you can know how you exited the program. Some people will write void main. That will definitely still compile, but it's not the standard or the convention. Then you'll have a sequence of statements that you execute as part of your main program. So we basically begin main with the curly brace and end with the end curly brace. So open and close. And again, we have declaration statements to declare things such as variables, and then executable statements to perform calculations, manipulate data, get input, create output, etc. And when we attempt to compile our program, we'll see any syntax errors that may have occurred in the program. So syntax error is something like in this little program that I've got here. I took off the semicolon at the end of the declaration for TMP. When I take that off, it produces some errors, and you can see those that are highlighted in blue there. And so you can click on those and you can see where those errors would occur. Generally, I start with the top one and click on that link, and it'll take me to somewhere near where that error occurred. I always fix the first one first and then proceed to fix the later errors, because a lot of times you'll get what are known as cascading errors. One error will cause a whole bunch of other errors to happen. So if you fix the first one, sometimes it'll fix several other ones that appear later. Some clues and ways to spot errors. Sometimes you'll see red squiggles if you zoom in or you have better eyes than I do. So there's where I left the semicolon off the declaration for the variable TMP. You can see a little red squiggle. And if you mouse over that red squiggle, you can get some text that gives you a hint as to what type of problem you may have encountered. And so this says, hey, I expected a semicolon at the end of this declaration, and says, hey, you can insert that semicolon. You can do that with Alt-Shift-Enter, or, you probably just type the semicolon. But I think it has ways to speed things up in that C-line integrated development environment, if you have a more complicated error. But for me, I would just type the semicolon. And this is important. Not having any errors or syntax errors in your code doesn't mean that it's working properly. The compiler just checks if the code can run at all. Does it make sense from a syntactical standpoint, not whether it makes sense from a semantic standpoint. So you can still have logic errors. You might not account for all the cases. You might have variables that are uninitialized or initialized improperly. You might have errors in the formulae or the calculations or in the algorithm itself. So you still have to run the actual code to verify that everything works the way that you wanted it to. And you want to test with a lot of different inputs. Another thing in terms of putting together your programs is you'll want to have blank space to separate numbers when the data is input. And the blanks are also used to separate reserved words and identifiers from each other and other symbols. And you can't have them appear within a reserved word or an identifier. All the C++ statements end with a semicolon. This is the statement terminator. Those brackets are not statements, and those can be regarded as delimiters. We'll get to commas a little bit later on, but they're used to separate items in a list. If you have a list of items, say a list of favorite numbers, you may come across the place where you want to use a comma. You can also use them for declaring more than one variable following a data type. Not entirely necessary, but you can do that as well. And it's good to make use of white space, vertical for blank lines, and horizontal indenting. We'll see that as we get into some of the control structures where that horizontal indenting is good. And I like to align the begin and end brace. Some people will put the begin brace on the same line as int main. I always put mine after so that I can see where they line up when I'm scrolling through the program vertically. And again, using those comments is important because sometimes we forget what it is that we were doing when we were writing the program, particularly if we come back and revisit it much, much later. So it's good to have those comments, for your sanity or anybody who's actually, going to maintain the code. So that's it for part 3. Thanks so much for watching.